So when it comes to chapter number 5, which is talking about class definitions and objects, the object-oriented programming paradigm, this will be the final lecture in chapter number 5. So we've got one more chapter after this, which is talking about arrays, and that's chapter number 7. So for the conclusion of classes and methods and objects, we're going to take a look at the puppy class. The puppy class is actually fairly complex. You'll be looking at some of the features in the following semester, in the following course for this. But it's actually a really good example because it does cover all the basics that we've been looking at almost from the very beginning of the course. So we're going to be looking at basically storing information all the way up to creating objects which can interact with each other. So it's a fairly robust example for object-oriented programming. So the puppy class. It's also fairly cute. Okay, settle down, settle down. We've got puppies in the area. So what are we actually going to be doing with the puppy class? Well, we're going to take a look at object-oriented programming from a design perspective. We're not just trying to solve a simple little problem, just display hello world. We're actually going to try and solve a problem. But when it comes to software design and development, when we're trying to solve these problems, we don't just attack the large problem right away. We don't just open up the Java environment. We don't just open up Dr. Java and then just start writing a program from the very beginning. No, we actually have to think about what we're actually trying to accomplish. So we have a much larger problem. If you want to write a video game or you want to write a network-based data transmission program, you have to have a goal as to what the larger problem is that you're trying to solve. But you don't just start at the beginning and then write a bunch of code and compile it, and then you're done this big, massive program. If programming was that easy, literally everybody would be doing it. But there is more to it. And this would be similar to designing a house or planning out how you're going to make a trip from one city to another. You don't just get in your car and simply drive. You have to actually have a plan of how you're going to get there, maybe a route. So we actually have to break it down into smaller pieces. And that's really the foundation of software design and development. So we consider the larger problem. We have to know where we're going to be at the end. We know, when are we finished? When do we actually complete it? But we look at smaller pieces. And if we can make these smaller pieces self-contained, then so much the better. Because a self-contained component, you can test it. You can actually give it to somebody else. It has no dependencies on other pieces. And if that doesn't go back to the definition of what we've been talking about for encapsulation, I don't know what does. That is the fundamental idea of self-contained components. It's this idea of encapsulation. We've seen it when we've been writing methods. We've been seen it when we've been writing programs. We have like one method in there, the main method. It does exactly what it's supposed to and the program finishes. So we have been doing this from the very beginning, but we haven't really written very large programs. There's a lot of topics to cover in the course, so we can't just focus on one big massive program. So we have been looking at small self-contained components. To help us with this idea of taking a larger problem and breaking it down into smaller components, the object-oriented programming paradigm, which Java supports very beautifully, actually helps us do this idea. And as we've pointed out, it's that idea of encapsulation. We can focus on smaller problems. We don't have to write everything all at once, compile it, and hope it all works. We can focus on smaller pieces. And those smaller pieces can actually work independently of other pieces. So when you're finished, that little piece is finished. You can give it to somebody else. You can put it aside. If you're actually interested, you could maybe put a method into your own utility class. You can look at smaller pieces. And that also comes back to the idea of being a lazy programmer. If it's going to take you 3 months to write one big massive program, it would be much easier if you could focus on smaller pieces that might be able to take you a day, a few days, or maybe a week to write. And once you finish them, you never have to look at them again. That's a pretty lazy way of doing it. Maximum benefit for minimum effort. So the idea of object-oriented programming falls completely in line as to how we should be writing software. So the idea is to break them down, break down the pieces. And if we can take our problem and implement it with an object-oriented approach, we can create classes that encapsulate an idea, maybe encapsulate functionality. And once it's finished and we've tested it and we know that that class defines the exact object we need, we can just put it aside, use it, but we never have to go back and change the code. And that's actually another aspect of object-oriented programming. Once the code is finished, we can use it as often as we want, but we never have to go back because we know it works perfectly. Think of the idea of the string class or the scanner class or even the random class. We don't have to understand how the string class does its stuff. We don't have to understand how the random class generates random numbers. We can just go ahead and use those classes. Some other programmer's responsibility was to encapsulate the idea of being a string or encapsulate the idea of producing random numbers. We don't have to focus on that again. So we're going to take a look at that idea, and we're going to use the puppy class. So here's the definition of the puppy class. So the problem statement would be, we want to write a computer game that simulates managing an animal shelter, because that's adorable and cute. Now, it doesn't have to be a game. It could be a real-world business simulation, but it'd be nicer if it's a game, because then no real puppies are going to get damaged or lonely in this simulation. So we need to make some decisions on conducting the shelter. So how animals will interact, which means we have to store some characteristics about the animals. If we're simulating an animal shelter, well, we have to be able to simulate the animals themselves, not just the shelter as a business. So we're going to look at one of the aspects, which is the animals. And one of the animals, of course, that you might have in a shelter, you might have dogs, you might have some lizards, you might have snakes, you might have some insects, who knows? But you'll definitely have a dog. So you'll need to have some sort of definition of what it means to be a dog. Now, we could have called this the dog class example, but that's not as cute as calling it the puppy class. So we're going to encapsulate an idea of a puppy. So this simulation will have various animals. It'll have the business itself, but one of the things it'll definitely have is being able to represent a single puppy, so that we could create instances of that puppy class, so we could have various puppies and dogs at various ages and various genders, all interacting within this simulation for an animal shelter. So I think that's actually fairly interesting. So let's take a look at what it means to be a puppy. So in this program, to be a puppy, we're going to have both attributes, which are the data representations of that puppy, and then certain methods. And methods, from what we've been looking at, are the actions. So what is a puppy capable of? Not a particular puppy, but what is any puppy capable of? So those are going to be the methods. So if we look at it using a sort of a general UML diagram, we're going to have our attributes that all puppies will have. They will have unique data values for those attributes, but they will also all have these capabilities, these methods. So all our puppies will be able to walk. They will be able to feed or eat. For female dogs, we will need to know if they're pregnant. And as time goes on, we can advance the pregnancy. So it goes from 1 month to another month. For all the various attributes, we'll be able to get and set those values. So there's our accessors, our gets, and our mutators, our sets. But also, as we've called them, our getters and setters. And for those of you that know about dogs, Irish setters are a breed of dog. So I thought that was funny that we're going to have setters. Also, we have our constructors. So when we first create a puppy, we're going to have the ability for a puppy to essentially come to life. And when a puppy comes to life, it's going to need a name, an age, a gender, whether it's female or male, and whether it's neutered. So that we'll need to be able to record that information about that particular puppy. So we've got all these methods. And if we look up here for the attributes that we're going to be manipulating with those methods, each puppy will have a unique puppy ID, and this is something that's going to be set automatically. And of special note, we're going to be using a static attribute here for puppy ID. That'll be something fairly unique to this example. Each puppy also has a name. Each puppy has an age and a gender. So now gender will be male or female, so that's why it's a char. Neutered will be a Boolean, so whether it's neutered or spayed, male or female, it'll be a true or false. And then hunger is going to be an integer, which is going to define how hungry a dog is, because it is a simulation. So we're trying to actually represent the real world. Dogs are hungry. And dogs can get exercise. Now, in this example, when we look at it, as a dog exercises, it will get hungry as well. And also for female dogs, is it pregnant? And how many weeks pregnant is it? So we've got all these characteristics and attributes, for the puppy class, and we've got the methods, or the things that the dog can do. This isn't a complete example. This is a very simplified form. We could look at various other things for puppies. We could have a puppy if it was going to play. We might have two dogs interacting with each other in terms of play. So while they're playing, obviously they might be getting hungry. So the more they play, the more they're exercising, and the hungrier they get. And as time goes on, a dog also will get old. So we would have to have some sort of method that manipulated the age attribute. So at the moment, we don't have anything in the methods here that say grow older. So we don't have a complete set of methods for the puppy class. But let's take a look at breaking down those attributes and those methods and seeing what the data actually is for those. So let's take a look at the puppy class here. So we have we've got the attributes. So if we look at the attributes, the puppy ID is just going to be a single number. It'll start counting at 1, and then every time we create a brand new puppy, it'll get a brand new ID. So it'll start at 1, then 2, 3, 4, 5. As puppy objects are created, we're just going to increase this puppy ID. So each puppy will have their own unique ID. Now this is just something internally that the program will use just to be able to distinguish the puppies from each other. But it's not something that the puppy is going to have, around its neck or on its collar or something like that. This is just an internal ID that the program will be using. The name itself is obvious, what the name of the puppy would be. The default value is no name. So if we create a puppy using the default constructor here, you'll notice that the default constructor doesn't have any parameters for name, age, gender, or neutered. So what values would it get? Well, for the default constructor, it will just have the name as no name. So if we see a puppy with no name, clearly it hasn't been fully created in the program. We've got the age, which is indicating the years old that the dog is. If a dog is 0 years old, as a note here, that would mean it's less than 1 year. So a puppy that's 2 or 3 months old, it would be 0 years old. We've got the gender, so that's just a char, a character variable. So M for male and F for female. We need a default value, so we just made the default value M for male. Of course, a programmer or the program itself would change that accordingly depending on what we want to represent. We also have that it's neutered, true or false. So whether it's neutered or spayed, the default here is false. So for a brand new puppy object, it would be unneutered. Also, hungry is a value that goes from 0 to 5. If the hunger value is 0, it's not a hungry dog. It's not a hungry puppy. If the value is 5, it's extremely hungry. This dog wants some food. The default for this is 5. So as soon as a puppy object is created, it is hungry. And I think that's about as real as you can get when you're simulating a puppy. As soon as a puppy is born, if you ever had one or you've ever seen one, they are hungry. So we're going to default that to 5. It's going to be a hungry dog. Exercise is going to indicate whether or how much the dog has been exercised. So if it's 0, it means it has been exercised. This dog does not need any more exercise. If anything, it's exhausted and it's tired. 5 would be that it's not exercised. So the default here would be 5. So as soon as a puppy object is created, we're going to assume it's not exercised. Another way to look at this exercise value could be the amount of energy it has. So at 5, which means not exercised, this dog has a lot of energy. At 0, it means it has no energy because it's been completely exercised. This dog is exhausted. And we might have a relationship between the hunger and the exercise. So a dog that is exercised, its value is 0, is probably a very hungry dog. Also, a dog that hasn't been exercised possibly is not very hungry. So we might have a relationship between these two attributes. And we've also got, if the dog is female, how many weeks pregnant is it? So in this case, 0 would mean it's not pregnant at all, up to a maximum of 9, which is possibly this dog is ready to give birth. So we've got the value as an integer there from 0 to 9. And that would be indicating the number of weeks pregnant it is. Now, of course, this would be only if it's female. So this attribute is actually special because it will only have a value of non-zero if that puppy is female. I mean, it could be female and it's not pregnant, but if it's a male, definitely it's not going to be pregnant. So those are the attributes that we've got for this class. And if we take a look at the methods, here are the methods as we've designed them. So we've got two constructors. So when we create this puppy, depending on how we create it with the new operator, if we don't provide any parameters, it's just going to set it to the default values for every attribute as we've seen. So for the puppy ID, it'll be whatever the next puppy ID would be. For the name, it would be no name. For the age, it would be 0. If it's a gender, it would be male. If it's neutered, that would be false. The hunger level would be 5. Exercise would be 5. And female weeks pregnant, 0. So those would be the default values for our default constructor. But if you did create a puppy and you did pass in all those values, you would be able to assign the name, the age, the gender, and the neutered. Now, of course, you can't change anything else with this. You can't define this as saying, I want to create a puppy, and initially I'm going to make it not hungry. That doesn't get set through this constructor. This constructor only sets those 4 parameters. Because of design, that's the way this class has been designed. Later, of course, you can set those particular values. So you can set the name, the age, and the gender as well, but you can't set the other values. So you'll notice that there are no sets for the exercise and the hunger level. And we'll talk about that one. Set weeks pregnant, you can force the weeks pregnant that the dog is, because this is an animal shelter. Animals might be dropped off, and you are then basically defining and saying, okay, we have a brand new puppy here. This puppy is obviously, it might be 3 years old, and it's 4 weeks pregnant right away, because that's how it was dropped off. So it's not something we can define in the constructor, but as soon as we've got a puppy object, we immediately can do a set weeks pregnant for that puppy object. And we've also got the accessors or the get methods. And in this one, we can get every individual attribute except for neutered. We're going to actually call something is neutered for that one. So we're not going to have a get method, which means get whether it's neutered or not. We're going to actually write something called is neutered to actually get the value back. For the pregnancy, once a dog is, maybe it is pregnant, it's female and is pregnant, you can actually call the advanced pregnancy method. So you can take your dog object and just say advanced pregnancy. Bam, that dog is now advanced by 1 week. You can also set it, how many weeks pregnant. But each dog has the ability to just advance its own pregnancy, which sounds strange, but this is a simulation. So the dog object, regardless of what level of pregnancy it is, you can just say advance the pregnancy. Think of it as pregnancy plus plus. So we're just advancing it by 1. And once we reach 9, obviously the dog can't be more pregnant than that. So this one would enforce the fact of being able to only advance up to 9, and that's it. Of course, there is no unadvanced pregnancy. There's no pregnancy minus minus. That wouldn't make any sense. So of course we don't have it. We can also ask, is a dog pregnant? We can just say, is pregnant. And that's very similar to is neutered. It comes back with a true or false value. Then the last two are probably the most entertaining. With the dog, you can feed a dog. You can basically say your dog object dot feed and then dog walk. So if you ask it to dot feed itself, what it means is that we're going to increase the exercise by 1. So as we're feeding the dog, we're increasing its feed level. The walk method. So if you said to your puppy object dot walk, that will reduce the exercise level by 1 because now it's getting more tired. And it'll also increase the hunger level by 1 as well because it's getting hungry. And of course, as the more you exercise, the hungrier the dog will get until the exercise level reaches 0, and possibly the hunger level has reached maximum as well. So the walk method is interesting because it will actually manipulate 2 different attributes, both exercise and hunger. So if we go back and look at our attributes here, we've got our hunger level and our exercise. Those are independent data attributes for this object, but the walk method is able to manipulate both of them. So every time you say dot walk, it will reduce the exercise by 1 and increase the hunger level by 1. Whereas the feed doesn't affect the exercise level, or it doesn't affect the let's see, actually no, now that I'm looking at it, it does manipulate both of them as well. So it does reduce the hunger by 2 because as you feed the dog, it gets less hungry, and you increase the exercise level by 1, which means as you're feeding the dog, it's getting less hungry, but it should need some exercise because it's getting more energy. So the exercise level gets increased. I missed that. So we've got 2 more methods for this this puppy class. We've got an equals method and a toString. So let's take a look at the equals method very closely here. What it means is I'm going to be able to compare 2 puppy objects together. So I'm going to see if 2 puppy objects are equal. Now what does that mean? We can define our own definition of equals method for the puppy class. So what it means to be equal is if 2 puppy objects are equal only if the genders are the same and the age difference is less than 2 years. So 2 puppy objects, we're not going to worry about their puppy ID, their name, their neuter level, their hunger, their exercise. We're not going to care about that for equality. We're only going to look at if the genders are the same and if the age difference is less than 2 years. So a puppy that's 1 year old and a puppy that's 2 years old, clearly they are within the same age range. And if they're both female, as far as we're concerned, those 2 puppies are going to be equal. Now, we could have added, as you've been thinking about it, in attributes, one of the things we might be missing could be the breed of the dog. So whether it's a Chihuahua or whether it's a Corgi or whether it's a Labrador Retriever, but we didn't have that one in there. As I said, this is not a complete class, but we could have added that into the equals method as well. So for 2 dogs to be equal to each other, we could have considered the gender and then the age difference less than or equal to 2 years and that they're the same breed. So that 2 Corgis might be equal, but a Chihuahua and a Corgi, even though they might be about the same height, they're definitely not equal to each other, even if they're the same gender and within the same age range. So we're going to write our own special equals method for puppies. And then last but not least, the most probably in some cases the most important method is the toString method. So you should be able to ask a puppy object, display yourself. Give me back your information, but not as specific individual values. I don't need to know specifically what the age is or specifically what the gender is. I just want whatever the dog object is going to return, just return it in a string and I'm going to display it. It'd be very similar to just asking the die object, print yourself, and it just goes ahead and displays itself. So We've got some examples here. So if I asked a particular dog to just, or a particular puppy to display itself, I might get back a string that would look like this. It would say that Sniffles, which would be the name, is a 2-year-old female, is not pregnant, is not neutered, and the hunger is at 1 and exercise at 3. The object itself returned a string like that. I didn't have to pick out those particular values as a programmer. I'm just having the object display itself. And you'll notice that it's creating all this string content from the attributes. So it's going in, it's picking out the puppy ID, it's picking out the name, it's picking out the age, it's picking out the gender, it's picking whether it's pregnant, and you'll notice because Sniffles is a female, we describe whether it's pregnant or not. We also know if it's neutered or not, and the hunger and exercise levels. For the second example, we've got the puppy ID being 2. We've got the name of the dog being Mumford. Mumford is a 0-year-old male. 0-year-old probably because he could be 3 or 4 months. Is neutered, and the hunger level at 5 and the exercise level at 1. What seems to be missing in here is the fact that we don't know anything about the pregnancy. But keep in mind, this is a male. A male puppy couldn't be pregnant, so we're not even going to mention the pregnancy. It's not something we do. So the toString method has to be aware of the fact of whether the puppy is male or female in order to put that pregnant data attribute in there. And then the last but not least here, we've got puppy ID 3. Trudy is the name, is a 5-year-old female, so we've got the age and we've got the gender. Is 3 weeks pregnant. Trudy is pregnant by 3 weeks. Is not neutered, and hunger at 0 and exercise at 0. Well, that's an interesting one. So hunger and exercise, all that information is in there, all produced by the toString method. We're going to take a look at the toString method of how it works. So we're going to take a look at the code now. Now, where exactly is the code? Well, all this information is on our Moodle page. So for the puppy example, we've got the notes that we've been looking at. Those are the puppyexample.pptx. The code itself for the actual class is puppyjava.txt. And then a very simple main method, which goes through some examples of using these methods for each individual puppy. That's the shelter game tester. So these 3 files here are what you need for following along with this little virtual lecture. But you can take a look at the code. You don't have to write the full class to play around with the shelter game tester. You can just download it and take a look at it. So let's take a look at the code right now. So I'm going to fill out the shelter game tester. It's going to be following exactly what's posted on Moodle, but for right now, we're going to look at each individual thing as we go through creating the main method to test out the puppy class. I've also got the full puppy class over here, and we're going to take a look at the various pieces of it. So we've got the various components at the top, which are the attributes, and then we have all the methods down below. So we're going to go through each individual method. So let's take a look at the very first thing, and that will be part of the constructor. So if we go back over here, we've got these 2 constructors when a puppy gets created. So let's take a look at what the code is for creating a brand new puppy object. All right, so there's the code that creates a puppy, and we're going to call it dog1. So create a puppy object and reference it as dog1. So in memory, we've created a brand new puppy object. We've used the default constructor here, and the new operator, we remember, returns back a memory address, and that's going to be referred to as dog1. So dog1 is storing the memory address of a brand new puppy object. Now this puppy object has all the default values. What are those default values? Well, let's take a look at the puppy class. So if we look at it, we've got all the attributes listed up here at the top. Now this is also why we declare things at the top. So when it comes to a class, we declare our attributes at the top of the class. When it's a method, we declare all our variables and so on used in the method at the top. Grouping them together makes it very easy to see. So let's take a look at it. We have the puppy counter, which we're going to come back to in just a moment. We've got the puppy ID itself, which is just an integer. We've got the name of the puppy, and you'll see that it's got a value of no name. That's the default value. The age is 0. That's our default. We've got our gender as male. We've got our neutered as false. We've got our hunger level at 5, and exercise level at 5, and weeks pregnant at 0. And that falls in line with exactly what we were talking about when we set our attributes here. We decided these are the attributes and all the default values. It was part of our design. So we've set all those values up here. So what we have, let's focus on this area. These are all the attributes that every puppy object will have in this class. So whenever we create a puppy object, every single one will get a puppy ID, a name, an age, gender, a neutered, a hunger, exercise, and weeks pregnant. They all get that. They also get these up here. So these 3. So we've got some constants up here. So we've got a public static final char male. So these are constants because they're final, and it's referred to as male. That's just replacing the M value and then female for F, so that later on in the code I can just use the term male, and that's going to be a character M, and then female for a character F. And that's only to make things clear, so that in the code I can see male and I can see the word female. I'm not seeing M and F and trying to remember that, oh, the M stands for male, it doesn't have another value to it. If this was a string, I could probably store the gender as a string called male or female. But as part of our design, we decided that the gender is a char. So it's going to be an M or an F. That was part of our design. So just to make the programmer a little easier to, or make the program a little easier to follow, let's use the entire word male or female. So I just created some constants. Just makes my program a little easier. Think of it like math.pi. You don't have to remember 3.141597. You can just say the word pi. So that's what I've done with male and female. Now this is the one that we have to pause for just a moment and talk about. The puppy counter. You'll notice that all the other attributes here are just declared as private, but there's no static. So these are all dynamic, which means every single puppy object has its own puppy ID, name, age, gender, and so on. But all the puppies are going to share this thing up here called the puppy counter. And that's because it's static. And if you remember, when we were talking about static, the definition is, if something is static, it always exists and there's only one, which means that there is only one puppy counter that all puppies will share. And this puppy counter always exists. As soon as the class puppy is loaded into Java's memory, as soon as it's loaded into the virtual machine, immediately puppy counter has a value of 1. The program hasn't even begun running yet that uses the puppy class, but the puppy counter will have a value of 1 right away. These other attributes won't actually exist until we start creating puppy objects. But the puppy counter, because it's static, will always exist, and it already does. And because it's only 1, all the puppy objects are going to share it. And we're going to come back to this as we start creating puppy objects. We're going to see how the puppy counter is used and how this idea of it being static actually helps us do an automatic count to create the puppy ID. So the puppy ID itself is unique to every puppy. So as a puppy gets created, the first one will get a value of 1, the second one gets a value of 2, the third one 3, and so on. But how does the puppy object know what puppy ID it's supposed to get? That will be based on the puppy counter. Every time we create a brand new puppy, we're going to increment the puppy counter by 1. And because that puppy counter only exists as one instance, every puppy will be able to see it and see what the value is. So we're going to come back to this one as we start creating puppy objects. So let's get back to our shelter game tester here. So here's our puppy, and we've just created it. But let's actually display it. We haven't done anything else, but let's go ahead and do a systemout.println of our puppy called dog1. That's all we're going to do. Display dog1 characteristics. So we're going to have dog1 display itself. This syntax is similar to actually saying toString. So by not putting anything in there, by just using the reference dog1, we are going to be calling the toString method. So let's take a quick look at what toString does. So if we go down into this class, we'll go down all the way to the bottom, and here's our toString method right here. So let's see what it does. So the very first thing it's going to do is create a string which is for the return of all the values. And what we're going to do through this is we're going to keep adding to this string. Now, don't be mistaken that the toString method is a systemout.print or println. The toString method has nothing to do with displaying to the screen. The display of the screen is done by the main method actually doing a systemout.println. But it calls dog1 and dog1 as an object because this syntax is actually calling the toString method. This returns back some sort of string, which is then displayed by the println method. What is the string that it returns? Whatever the toString method returns. So we've declared our temporary string here that we're going to populate, and at the very end of the method, we return it. So let's take a look at how it's going to build it up. And keep in mind, this example here, where we had Sniffles and Mumford and Trudy. So we're going to build up a string that has the name of the puppy, the age that it is, the gender that it is. If it's female, we're going to say whether it's pregnant or not, and if it is pregnant, how many weeks it's pregnant, whether it's neutered or not, the hunger level, and the exercise level. So we're going to display all the attribute information in a very nice readable format. So let's take a look at how that's done. So we've got our string here. We're going to populate it first with the ID, the puppy ID. And that's similar to saying the ID colon whatever number it happens to be. So for this one, we're going to use our old friend here, string.format. So we're going to put in there the ID as text, and then a %d, which is populated by the puppy ID. Every puppy has his own puppy ID. So puppy ID goes in, replaces the %d, and that string is then returned and concatenated to our return string. The next is the name, and for that one, we're just going to say the name is, and we'll just leave it at that. So following is a, we're going to put the age itself after that. So we've got this syntax. Sniffles is a 2-year or 0 year. So we've got the age following along. So we've got the name is a however many year old. Then we have to figure out if it's male or female. So for this one, instead of using an if statement, we decided let's just go ahead and put in a conditional operator because we're going to return back the word male or female. That's the only options we've got. And it's a perfect opportunity to use the conditional operator here, the question mark operator. So we ask the question, if the gender is equal to male, then return back male. Otherwise, it has to be a female. So return back female. Where did this word male come from? Well, if you go back to the top of the code, male is just a char. So that's a primitive data type, which means we can do this double equal sign stuff. We're not doing any string.equals here. Pretty straightforward. So at this point, we have the puppy ID, we've got their name, their age, and whether they're male or female. And that's a perfect end of the sentence. And you'll notice that this is where that period comes from. So if you look at our examples, every one of these after male or female, there's a period. Where did the period come from? That's actually in the string that says male or female. Like, we're being just super lazy here. We're making it format. We're making it look awesome, but there's not that much code to make it work like that. Now, the next part is whether we talk about whether the dog is pregnant or not. We're only going to do this if it's a female. So we've got this big if statement here, which is going to format only if it's a female. So we've got gender female. If that's true, then we have to figure out what kind of text we put in there. So for this one, we're going to say if the weeks pregnant is equal to 0, clearly this dog is not pregnant. So we're going to concatenate the phrase is not pregnant. Otherwise, if the weeks pregnant is greater than 0, we're going to concatenate is, and how many weeks pregnant? Weeks pregnant. So now we've concatenated another string. We could have done this question or this if statement here as a conditional operator, but it probably would seem fairly long. We've got is not pregnant, we've got this big massive second string. So the design said, you know what, let's just write it as a big if statement because it's much more clear writing it this way. But this will only apply if it is a female. If the gender is male, this if statement will not execute. So we're not going to talk about any pregnancy if this is a male. So then we're going to come down and we're going to figure out if it's neutered or not. And because this one, again, it's a very simple thing to say because neutered is a Boolean. It's true or false, another conditional operator. So we put the phrase is neutered or is not neutered. And then finally, we're just going to add the hunger and exercise levels. And this is pretty straightforward. We're just going to put in there hunger at, whatever the hunger level is, slap a period at the end, exercise at, put in the exercise value, and put a period at the end. So all of this string concatenation is going to happen, and then we're just going to return the string. And that follows along with an example. So what we should see for this first dog, if we go back up to the top of the code, what we called is this constructor here. So if we look at our shelter game, we asked to create a brand new puppy using the default constructor. So over here, this is the constructor that matched. Java's going to match up the signature here. We've got our method header. This is a constructor, so there's no return data type. There is no parameters. This is the one that executes. So let's take a look at what happens inside. So for this constructor, the idea is that we're going to set all the attributes to their default values. Now you'll notice up here, as soon as this object gets created, these already are the default values. So we don't have any more work to do. All the defaults have been set above. So that's awesome for us. It's a little lazy programming there. Now in this one though, we're going to set the puppy ID. So for the very first puppy we create, it's going to reach over, grab the puppy counter value, and we've defaulted it to 1. So as soon as the puppy class gets loaded into memory, this puppy counter is going to get a value of 1. And because it's static, it's already there before we even create the very first puppy. Now that we're creating the very first puppy, we're going to pull the puppy counter out and we're going to store the value into the puppy ID. So that should get a value of 1. Now because this is a plus plus, the rule for plus plus is that we take the puppy counter, we return the value, and then we increment it by 1. So after we've executed this constructor here, this constructor method here, the puppy counter is going to be now 2. So now we're ready for the next puppy. It will get that value of 2. And as it gets created, it will call the constructor here, which will then increase the puppy counter again to 3. So the puppy counter is actually shared by all of them. So let's take a look at what we have so far though. Let's just take a look at just this one puppy. We'll talk about the puppy counter in just a second. So let's compile this to make sure that all of this works. All the code compiles nicely, and if we run it, we should see a dog that has no name and, well, has all the default values. So there we go. You can see our toString method has returned back this string here, which is that the puppy ID is at 1. No name, which happens to be the name of the dog, is a 0-year-old male, is not neutered, hunger at 5, exercise at 5. Those are all the default values, and that's what the default constructor has done. Awesome. So let's create another dog here. So we'll clear this out and we'll create another dog in this place. All right, so we have a second dog, dog 2. Well, I'm not being too creative with the reference names because I have these great names inside. So in this one, I'm going to create a brand new puppy, but I'm also going to pass in the parameters. Now I've got 4 parameters that I can pass in. So if I look over at my puppy class again, we've got the default constructor, which has no parameters, but then we have this one here, which has the 4 parameters. We've got the name, we've got the age, the gender, and whether it's neutered or not. And if we look at the signature for it, the name of the constructor is called puppy, and then the parameters are string, int, char, and boolean. So that is the signature. So if we go back up here, we have a string, int, char, and boolean. That will match the signature of that constructor. So we're creating a brand new dog here called Piffles. Piffles is 3 years old. It's a female, and true, which would be the last one, being that it's neutered. Awesome. Now you'll notice that this syntax here, puppy.female. If you go back into the puppy class, we've got female and male. But we've also made these public instead of private. All these attributes here are private, which means they are hidden inside. You can't reach from the outside. I can't say dog2.name. I can't manipulate the dog's name. Let's actually try that in the code after we compile it the first time. But I can reach over and grab whether it's female or male. I can actually grab these identifiers. These are public static. They always exist, the same idea as the puppy counter. As soon as this class is created, I can just reach over and grab these statics, and I don't have to declare an object to use them. I can just use the name of the class. Very similar to how I use the math class, math.py, math.min. The math class, everything it has is static. It's a static utility class. So I can just reach over and grab puppy. As soon as I did this, though, as a side note, puppy class is now a hybrid class in a way. Because of the fact that I have some static attributes here, and 2 of them happen to be public, this is not a fully dynamic class. This is, unfortunately, a hybrid class. But as a programmer, we can just sort of forget that, because hybrid is just a definition. And even dynamic class is just a definition. I'm using my class as a dynamic class. I just happen to have these cute little thing called male and female, which I can pull out at any time. So let's take a look at what we've got here. So let's display dog number 2. So I'm just going to say dog2. That will call the toString method for dog number 2. Let's compile. Seems to run, so I could create my second puppy. And there we go. So dog ID 2, Piffles is a 3-year-old female, is not pregnant, is not neutered, hunger at 5, exercise at 5. And these are the default levels, which we can't change. We can't change them as part of the declaration of creating our puppies. And you'll notice that the ID is 2. So the first ID of 1 goes to dog number 1. The second one goes to dog number 2. So let's take a look at what that means for this puppy counter. Now that we've got 2 puppy counters, let's take a look at that. So when the puppy class is loaded into the computer's memory or into the Java Virtual Machine's memory, and that would be whenever a program is using the puppy class, so it's loaded into memory, before we create any puppy objects, this is sort of how it looks. We've got the puppy class definition, so we've got all the attributes in there, we've got all the methods that belong to the puppy class. But in particular, we do have the puppy counter and it's set to 1, because this is a static. So if we go back over to the puppy class, we've got the puppy counter here, it's a static. It exists regardless of creating any objects of the puppy class. So it's sitting there and it's got a value of 1. So what happens when we create the very first puppy object? And that would be dog1. So we create dog1 here, and it's going to get a reference to a brand new, because we've got the new operator, the puppy object here. So we've got a reference there, a memory reference to dog1. It's pointing to this object in memory. The puppy counter within this object here is actually referencing the puppy counter over here. So this object, this dog1 object, if you will, doesn't have its own puppy counter. It's referencing the puppy counter that belongs to the original class. And if we go back over here, you'll see the very first thing that happens is we take whatever value is in the puppy counter and we put it into this object. So it gets the value of 1 because the puppy counter is a 1. And since the puppy counter statement was puppy counter plus plus, what we do is we increase the count for puppy counter. But this is a static and it's referring back to this one. Why? Puppy counter always exists and there's only 1. So that's what static is implying. So we've changed this value to 2. So the puppy ID here has been set to 1 from what puppy counter used to be, but now the puppy counter is 2. So what happens when we create our second puppy? So if we go back over to our code here, we've got dog2 being created. So what does that look like? So now we've created our second puppy. So that one is called dog2. So dog2 refers to a brand new puppy object. So we look at the code again. So we see that puppy2 is being created and we pass in the name like Piffles and so on. But let's take a look at the puppy counter. So we know that the puppy counter here is a static, so it's going to be pointing back over to this one. So let's go back over to the puppy class. We look at the second constructor. We'll come back to all of these attribute things in a moment, but you'll notice that we do a puppy counter. We take that value, we assign it to the puppy ID, and we do a plus plus. So we take the puppy counter value and we assign it to the puppy ID. That's set to a value of 2. Because that's what the current puppy counter value is. And then we do a puppy counter plus plus, but it's not this puppy counter here because we know it's a static. There's only 1, and this changes to a 3. So you'll see that the puppy counter is actually shared by all the puppy objects. In a way it's shared, but they're all just pointing back to the same memory location, which is within the puppy class itself. All the statics belong to that class definition. So that's why static means it always exists. It's part of the class definition. It's not part of the objects themselves, and there's only 1. As soon as we're defining this static, if this object changed the puppy counter value, which it did a plus plus, so it changed it for everybody. So this one also changed it for everybody. So if we created a third puppy object and we used a constructor to get the puppy counter value, we would store the puppy counter value or the puppy ID as 3. We would do a plus plus and it would change the puppy counter to a 4. That is one of the cool things about how Java actually does object-oriented programming. It lets not only objects have their own data, but it lets objects share information as well. It's almost a weird sort of telekinesis because this object didn't actually have to manipulate the puppy counter value in order for the puppy counter value to change. If we go back over here, when we first created dog1, it manipulated the puppy counter value. As soon as we created dog2, it also manipulated the puppy counter value. But if this object here, for some whatever reason, displayed the puppy counter, we would see that the puppy counter is set to 3, not to the value of 2 that this object did. So it was created out of its context. That's actually something that not all object-oriented programming languages do. C++, Java definitely do this. Some of the other object-oriented programming languages don't actually permit this because it's outside the tenets of object-oriented programming. So it's a neat little trick here to have these individual objects create their own puppy IDs without actually having any code that really is passing that information back and forth. So that's actually quite interesting for the puppy class. It uses this static puppy counter to automatically increment the puppy ID, which is stored every single time. So let's go back over to this example. We were talking about Piffles. Piffles himself, or herself, as this case would be, gets created using the second constructor. So the second constructor, you can see down here, we have the name, age, gender, and neutered, but there's a problem with that. We called the parameters exactly the same as we had in the attributes. And this would cause a problem when we did something like this. So if we tried to assign the name by name is assigned name, which name is which? Is this name the first one, or is this name the second one? And is this name referring to the attribute, or is it referring to the parameter? Now, Java doesn't have a problem with this, except it would do it incorrectly. Java assumes that if you don't specify it directly, it's whatever is local to this method. And we know that parameters, so name, age, gender, and neutered here, are local to this method, which means that name is actually this name here, not the one that belongs to the object. So this is why we're using this syntax, where we say this dot name. What it means is the object is referring to itself. Which object? This object. So it's whichever object is being referred to. If we look at the example in this one, it would be dog2. It's whatever it is. I'm referring to myself. So that's where we say this dot name. This syntax immediately points to this name, whereas name on its own is clearly referring to the parameter. So we can take that name string, move the assignment over, if you will, make a copy of it, and put that into name. For the age, we have something called setAge. We have a setter. And we're going to take a look at setAge in just a moment. We've also got set gender. So we're going to pass in gender, and then neutered. And then, of course, the very last thing, as we've just mentioned, we're going to take the puppy counter value currently, store it to puppy ID, and then increment the puppy counter value by 1, because that's how puppy counter ++ works. So why did we do all this this set age over here instead of just saying this dot age is assigned age? We could have just used this syntax. Why didn't we? Well, let's take a look at that. Let's go down into set age. So we're going to go down here over to set age, and you'll see for set age, there's some logic going on. So we have an age parameter here, so age p. So that would be this age over here gets passed in. So we have a constructor method calling the setAge method, and the setAge method checks the parameter first, and it says, if the age is greater than or equal to 0, then set the age to the parameter value. Otherwise, if the age value happens to be negative, we're going to set the age to 0. This prevents us from setting a negative age value when we called it. So if we tried to set the age to -34, let's take a look and see what happens here. So remember, the age is -34. It compiles just fine because all the constructor is expecting is an integer in this sense. So it still gets an integer. But let's take a look at what age is actually set. A 0-year-old female. Why isn't it -34? Well, the reason for that, let me just make the change here back here before I forget. The reason for that, when we passed it in, the age was passed in over here and then called through the setAge method. The setAge method verified that the parameter value is going to be greater than or equal to 0. Otherwise, it's going to force the age to be 0. It's not going to permit negative values. Perfect. We have a little bit of security. This also prevents somebody, another programmer, calling this and setting the age to an invalid value. And if we look at gender, gender is going to follow the same idea. So we go down here into gender. So when we set the gender, we pass it in, and gender hopefully is male or female. So we come down here and we look at the char. The char for gender parameter here. If it's equal to male or it's equal to female, then set that value. Otherwise, it won't do anything. And there are only two options, male or female. But if we look at it, the gender is a char. There's nothing saying that we can't set it to T. T is a char. This should be able to compile just fine. And then we run it, and it seems to work just fine. Let's display this and see what value got set for dog2 when it tried to set the gender to T, which is a strange gender. I'm not quite sure. Let's see what it set it to a male. Why did it set it to a male? Well, if we go back up here, we'll see that the default value for the gender is male. And when we called the set gender method, here eventually would get passed a T because we had the T up here in the constructor. A T got set here when we called set gender. So this was a value of T. T clearly is not equal to male and it's not equal to female, which means it's not going to set it at all. And this gender is going to keep the default value that it had before, which was male. So that's why we got a male by setting it to T. This is a piece of security that we've got. This class prevents the data from being incorrect. And this is also why we have all these sets and gets. This is why we have the setters and getters, to verify the values. For name, it's a string. So it could be an empty string, it could be a full string, we don't have that much control. But at least for the age and the gender, we definitely know what values we're going to permit. For neutered, why aren't we calling the set neutered value, which we have down here? Well, for set neutered is a Boolean, it's true or false. You can't really have a wrong value. You might put an incorrect value in terms of what the truth is. Instead of setting it to true, it should have been false, but you can't set it to any other value. So that one is actually perfectly fine. So we've got these values. So here are our two dogs. Let's go ahead and create a third puppy. So there's our third puppy, dog 3, Shasta. Shasta is 7 years old. Shasta is a male, and Shasta is not neutered. So Shasta might get into a little bit of trouble. So now we've got 3 dog objects. And if we go back over here, we've got a third dog object inside. So that third dog object, or that third puppy object, got created here. We're going to reference it as dog 3. It's going to reach over, grab the puppy counter value, which is 3. It's going to store it. And then this is doing a puppy counter ++. So now the static, the common, the global puppy counter that's shared by everybody is now set to 4. Perfect. That is awesome. So we've got the third puppy up here. So let's display puppy number 3. Make sure that we've got all the right information in there. And there we go, ID 3, Shasta is a 7-year-old male, is not neutered, hunger at 5, exercise at 5. Awesome, we've created our 3 puppies up here. So what else can we do with our puppies? We can create them, but now we can actually manipulate them with the various methods we've written as part of our software design. We're not looking at the whole simulator, we're just focusing on one small piece of this whole program, which is just creating the puppy class. So let's see what else we can do. So we've got to the program, we're displaying dog 1, 2, and 3. We're doing a simple print line here just to do a line separator. And then we're going to feed dog number 2. And what does feed dog number 2 mean? What does the feed method actually do? Well, let's go past all our setters and getters. So now we're going to get further down here. We've got all the gets for all the various values. That's pretty simple. We've got the is pregnant and so on. Where is the feed? Where is, there is the beautiful feed method. So remember the feed method, if we looked at it, what the feed method would do is if the hunger value is greater than 0, It's going to reduce the hunger by 2, and it's going to increase the exercise by 1. So as you feed a dog, it gets less hungry, but it also requires some exercise. And it's not a one-to-one relationship. So as the dog you reduce the hunger level, the exercise level goes up by 1, but the hunger level goes down by 2. So let's see how that would work. So we've got the feed method here. So feed has no parameters. It's just called feed. It doesn't return anything because we're asking the dog to feed. So we don't expect it to return back any value. If the hunger level is greater than 0, we're going to set the hunger level less 2, and then we're going to increase the exercise level. So how do we do that? Well, we're going to call the set hunger method. So if we go over here, we can see the set hunger method. It gets a value for hunger, which is the parameter, and it's just an integer. Well, what integer is it going to be? It takes the current hunger value, and we know it's greater than 0. It takes the current hunger value less 2. So if the hunger level was at 3, we're going to pass in 3 minus 2. We're going to pass in 1. We're going to set the hunger level to 1. Now, of course, you're right away thinking, what if the hunger level is just 1? 1 is greater than 0. 1 minus 2 is negative 1. How does that work out? Well, let's take a look at what it does inside. The reason we have all these sets, we're going to set the age, we're going to set the gender, is for security levels. We've also got a set hunger method. The set hunger method is also going to be secure. So what it does is it takes the hunger value, whatever has been calculated, it's going to set it to the current hunger level, but then it does a quick check. If the hunger level is less than 0, if it's negative, it sets it to 0. Otherwise, it sets it to the hunger level. So if the hunger level was now calculated out to be 1, that's a legitimate hunger value, and it assigns it over here. So if the hunger level was negative, it just sets it to 0. If it was a value greater than or equal to 0, it sets it to hunger. But then we do one more check. What if the value is greater than 5? Because 5 is the maximum. If it's at 5 or greater than 5, we set it exactly to 5. But if it's within the range of 0 to 5, we're going to put it back to hunger again. So this little thing, this conditional statement, ensures that the hunger value, even though it might have come in as a negative value less than 0 or a value greater than 5, we're going to make sure that if less than 0, it's set to 0. If greater than 5, it's set to 5. This little method here is just a security measure to make sure that the hunger level is reasonable and legitimate. Again, this is why we're writing these methods. This is why we have this class. It's encapsulating all the proper values for a puppy. So outside here in the code, all we just said is feed. We didn't provide any numbers or anything else. But the methods inside are making sure that all these values are legitimate. So the feed value, we could just keep feeding a dog and feeding it and feeding it and feeding it. But at some point, the dog's going to stop eating because it's full. It's reached a value of 5. Now, of course, if we know some dogs in the real world, they'll keep eating until they pass out from too much food. But in this case, we want to make sure that our dogs are properly fed. So if you keep calling the feed method, it will only eat so much. So let's take a look at what happens here. So this is dog number 2. What we're going to do is bring it down. So let's comment out dog 1 and dog 3 out of the code. So what we should do is create our 3 dogs. We will display dog number 2. We will then feed dog number 2, and then we will display dog number 2. So every time we feed it, if you remember, feeding reduces the hunger by 2, and it increases the exercise by 1. So by default, what we have is the feed level is, or the hunger level is set to 5, and the exercise level is set to 5. So let's see what happens when we do this to the dog. We do 1 feeding. So Piffles, 3-year-old dog, not pregnant, not neuter, hunger is at 5, exercise at 5. That's where we start. As soon as we fed Piffles, the hunger level goes down by 2, and the exercise level tries to go up by 1, but it's at 5 already. So nothing changes there. So feeding the dog just reduces its hunger level. Its exercise level, it still needs to be exercised. So that's what feeding a dog. And if we fed the dog twice, so we did a feed and we did a feed right away, what we should see is that it's been reduced by 4. So that'll be 2 feeding iterations. So let's take a look at that. And there we go. So we started off at a hunger level of 5, but we did 2 feedings, which means we reduced by 2, and then we reduced another 2. So now the hunger level is at 1. And if we do one more feeding level, or one more feed, so that should be a total of 2 plus 2 plus 2. That should be less by 6. It should reduce the hunger level into a negative number, because that's definitely less than, and it didn't go negative. It kept it at 0. That dog has stopped eating. We've fed it so much it doesn't need to eat anymore. So we now have an interactive dog. We can just feed them, and what happens if we do something else to them? So let's walk our dog. So we're going to walk the dog. So let's go down here and we will, whoops. My keyboard's going a little crazy. There we go. So we'll copy this down. So what we're going to do is display dog number 2, the default. We're going to feed it once. We are then going to walk the dog and then display it again. So what does walking the dog mean? Walking the dog is going to reduce the exercise by 1 and increase the hunger by 1, but only if the exercise is greater than 0 and the hunger is less than 5. So if we take a look at the code that represents walking the dog, we go down here, we again have that if the exercise is greater than 0 and the hunger is less than 5, then we are going to exercise, set the exercise less 1, and set the hunger increased by 1. Now we haven't seen the set exercise method. For set exercise, it does exactly the same thing. So there's a security check here. We take the parameter, we set the exercise level, and then we're going to check the exercise level. If it's less than 0, set it to 0, otherwise keep it the same. If the exercise level was greater than 5, set it to 5, otherwise keep it the same. Exactly the same type of logic that we did for hunger to make sure that the value is legitimate. So let's take a look and see what happens here. So we're going to feed the dog, and then we're going to walk the dog. So let's see what we've got here. So we've started off with Piffles being hunger at 5, exercise at 5. We do one feeding. At the feeding, we set the hunger level to 3, so now we're not as hungry, but the exercise level is still at 5. Piffles still needs to get exercised. So then we walk the dog, and walking the dog decreases the exercise by 1, but increases the hunger level. So the hunger level went up by 1, but the exercise level is finally going down by 1. So you can see how the feed method and the walk method are manipulating the dog object. They're not returning any value. They're not doing anything in terms of interacting with the user. There's no parameters that you're passing, but the feed method and the walk method are manipulating the actual dog object. So Piffles is being manipulated, and those are just the changes of these attributes. So we're actually getting a fairly intelligent program here. We're controlling the dogs. We're essentially bringing the dogs into the shelter by creating them. We are then asking the dog to display itself, give us its information. You can think of a dog on its badge, it's telling you its status. We are then feeding the dog. We are then walking the dog. It's almost like a video game, except with dogs. So let's see what else we can do with this dog. So we wrote the equals method for a dog. And if we look back at what it defines to be an equals method for a dog, so for a dog to be equal, it means that the genders have to be the same and the age difference is less than 2 years, less than or equal 2 years. So if we look at the code for that, we go down all the way to the bottom and we scoot up just a little bit. So here's our equals method. So the way we're going to call it is we're going to say dog1 dot equals dog2. This is very similar to strings, where you said one string dot equals another string. This expression returns back true or false. And you can see that we've run it here. So we've got a false and a true. So let's take a look at the circumstances. So if we go back into the puppy class here, we've got the equals method right here. So it's going to be equals as the name. It returns back a Boolean or true and false, and it's passed in another puppy reference. So this puppy is going to be passed in that puppy. And that's actually a bit of a joke when it comes to object-oriented programming. This is the current object, and so therefore we call that the other object, because we want to see if this equals that. Well, programmers are not that funny, but they try. So we're going to have a return value, which is whether this equality is true or false. So we're going to assume it's false. And now we're going to try and prove otherwise. So the first thing we're going to do is figure out the age difference. Because remember, two puppy objects are equal if the age is less than or equal to 2 years. So now we're going to do an absolute value difference. We're going to take this age and subtract that age. So we're going to take the current puppy object, whatever it happens to be, and subtract from it the age of the other dog, of that dog. Now this might be a negative value depending on which dog is older. And that's why we're doing a math.absolute value. So that we don't care about a negative value, we want to know the quantity. So if the difference in age is 3, we don't care if this is equal to a larger value and this is smaller, or this is a smaller one and this is larger. We don't care. We're going to take an absolute value, get the difference, and that's all we care about. So now we have the age difference between the current puppy and then that puppy or the other one. So now we're going to check the gender. If the gender is equal, and remember gender is just a char, so we can do this double equal equality, and the age difference is less than or equal to 2, then clearly the dogs are equal to each other. So we're going to set the return value to true. Otherwise, we don't have to set it to false because the default value is false. This if statement tries to prove otherwise. We assume that the two puppies are not equal. This statement here tries to prove that they are. So then we return the value. And if we look at our test over here, we can see that in the first circumstance, we are testing if dog 1 equals dog 2, and dog 1 is our default puppy, which is at 0 years old, and then dog 2 is Piffles at 3 years old. So clearly, 3 minus 0 gives us 3, therefore they're not in the range of less than or equal to 2 years. So that doesn't work out. And if we look at the genders, the default, of course, for a puppy is male, and Piffles is a female. So for the first one, dog 1 definitely does not equal dog 2. So we get a false. But the second one, we ask dog 1 if it's equal to dog 1. Well, clearly, dog 1 and dog 1 must be equal to each other. They have the exact same age, which is 0, and they have the exact same gender, which is male. So clearly they must be equal to each other. But let's check out some other dogs here. Let's change Shasta to be 4 years old, and let's change Shasta to be a female. So now what we're going to do is just compare those two dogs. So let's take this statement out, and we're going to compare dog number 2 to dog number 3. So we're going to ask the question, does dog 2 equal dog 3? And they do, because they're within less than or equal to 2 years, and they're both female. Now, the thing about equality is it works in reverse as well. We can ask if dog 3 is equal to dog 2. So now, even though the objects are different, so we look back over here at the code, so even though the equals method, now instead of saying dog 2 is equal to dog 3, we have dog 3 being equal to dog 2. But the logic should still work because the age difference, again, we're taking the absolute value. We don't care which direction the age difference is. We just care about the actual difference. So let's run this. It should be true as well. And yes, the two dogs are equal to each other. So now we've got an equals method which lets us compare dogs. And if you look at the syntax, we're just saying dog dot equals another dog, or the puppies themselves. We don't really have to describe what the equality is. All we really need to know is that there is an equals method and what the equals method relationship is. We don't really care how the code actually goes about doing it. So we've used pretty much all of them except for possibly the sets and the gets. But for these values, we're just getting the return value. We're just asking the gender and just getting back the gender. That's all we're doing. So as a simple example of that, we can ask, let's comment this code out here. We can ask for this dog. Let's see, gender of dog 2. And we can just ask dog2 to get the gender. So it should return back a male or female, but as an M or an F because it returns back a char. So it tells us that the gender of dog2 is female. Beautiful. If we wanted to get a little bit fancy with this one, we could do something along the lines of displaying the full word male or female. But we sort of have that going on with the toString method. The toString method gives us all the information we need about that dog. So that is the puppy class. Go back over here. So we'll go back and look at what we've created. So we've defined a puppy class, which has a number of attributes. So any puppy object, any real puppy that we create, has those attributes. And the methods that let us manipulate the puppy itself. So the puppy information, we can set it either through the constructors or we can do a set. And if you remember, some of the sets, for example, the age and the gender, are very intelligent. They won't let us set those values incorrectly. We've also got the pregnancy, which we haven't taken a look at, but I encourage you to look at it yourself. So you can advance a pregnancy for a puppy that is pregnant, and you can ask if it's pregnant. Now those are also relatively intelligent. So if we look at the pregnancy-related methods, so is pregnant basically returns back a true or false, and it asks the question, is the weeks pregnant greater than 0? If it is, clearly that must be a pregnant dog. If this is false, clearly the dog is not pregnant. That makes perfect sense. Advanced pregnancy basically takes the weeks pregnant, so it actually comes up here and grabs the weeks pregnant and adds 1 to it. And then it does a set weeks pregnant. If we look at set weeks pregnant, it's actually fairly intelligent as well. So we get passed in a number, and this one first checks to see if the gender is not equal to male. If it is equal to male, the short circuit would mean this if statement doesn't execute and we don't set the weeks pregnant, because you can't set the weeks pregnant for a male. But then we also check to see that it's not neutered, because a female that is neutered couldn't be pregnant either. So if these two conditions let it pass through, which means it's a female that's not neutered, then we can set the weeks accordingly as well. Now we could probably also check to make sure that the weeks fall into a legitimate value, that we're not setting it greater than 9. But that would be something that we could finish off with this class. As I said, the class isn't fully finished yet. Again, we're missing some methods. We're also missing some attributes, basically like breed and so on. But for the sake of the example, this is a fairly complete class. And we could clearly add this into a much larger program, a simulator for the full animal shelter. We've encapsulated the idea of being a puppy. We could easily encapsulate the idea of being a kitten. A kitten would probably fall under some different circumstances. For example, you don't walk a kitten, but a kitten does play. So you could probably have a kitten.play method. And maybe a dog has a similar play method, where instead of taking it for a walk, you just let it play for a while. And I don't know how that would work for exercise or hunger, but you could probably come up with something that would let the walk and exercise and play and all those methods make sense. But I leave that up to you. For right now, I want you to take a look at this example, the puppy method. It's on the Moodle page, So we've got the description, which is all of these notes here that describe the class itself, and also the code, the actual puppy class, and then the shelter game tester, which has the main method, which lets us test that class, and just go through some of the methods. That's it. That's it for chapter number 5, which is all about classes and methods and so on. I encourage you to read the rest of slides number 5, but focus on the areas that the virtual lectures have covered. Next up will be slides number 7, which is going to be looking at the arrays and a very simple view of arrays and how to store information where you don't exactly know how much, but you know the data type. So arrays themselves are up next. All right, see you in the next lecture.